In this video, I want to have a look at something called radians. So for all of your mathematical lives, you've always measured angles in degrees. But today I want to introduce a new way of measuring angles, and that is in radians. So the way radians are defined is if we have a circle with a radius of r, so we've got two radiuses drawn there, we're going to call the length from this point here to this point here, so this length along here, we're going to give that the letter L, standing for the arc length. So this angle in the middle here that we're going to call theta, if we're measuring that angle in radians, then the angle is going to be equal to the arc length divided by the radius. That means that 1 radian is the angle that an arc of 1 unit in length subtends at the center of a unit circle. So a unit circle is a circle that has a radius of 1. So this circle has a radius of 1, and this arc length from here to here, so this arc length in here, that also has a length of 1 unit. So if the radius and the arc length are both 1, that means that this angle is going to be 1 radian. So a symbol for radian is like a little C up there. What we also know is that if we have a circle with a radius of r, then the circumference of the circle is 2 pi r. So that means that we can find this whole angle of revolution in radians. So to do that, we'd find our theta, so our angle of revolution, would be equal to the arc length. So if we're going the whole way round, that would be equal to our circumference, so our 2 pi r, over the radius of that circle, which is r, and then our r's can divide through, and we just end up with theta equals 2 pi. So we know that an angle of revolution in degrees is 360 degrees. So that's telling us that 360 degrees is equivalent to 2 pi radians. Now that also means that 180 degrees is equal to pi radians. Now that little fact that 180 degrees is equal to pi radians, that is on your formula sheet as well. All right, so now we have two different ways of measuring angles. We have degrees and we have radians, and we need to be able to convert between those two measurements. So let's have a look at some examples. For our first one, we've got 3 pi over 2 radians, and we want to convert that into degrees. So we know that pi is equal to 180 degrees, so we're going to have 3 times 180 over 2, which will end up giving us 270 degrees. Right, let's have a look at question 2. So this time we've got 60 degrees and we want to convert that into radians. So to do that, we're going to manipulate this. If we know that 180 degrees is equal to pi radians, then that means that 1 degree would be equal to pi over 180 radians. So that means if we've got 60 degrees, we're going to multiply this by 60. So we're going to have 60 times pi over 180. And that will give us pi over 3 if we leave it as an exact number. Sometimes you'll be asked to round it off, say to the nearest 2 decimal places. So let's have a look at an example where we're asked to do that. So this time we've got 50 degrees. So we're going to go 50 times pi over 180. And if you pop that in your calculator, you'll end up, correct to 2 decimal places, with 0.87 radians. And that's to 2 dp. All right, let's have a look at a fourth example. So this time we've got 1.145 radians, and we want to convert that into degrees. So this time we need to manipulate this thing again, but the other way around. So if we know that 180 degrees is equal to pi radians, then that means that 1 radian would be equal to 180 divided by pi. So that means to turn this into degrees, we're going to go 1.145 times 180 over pi, which would give us a decimal when you put it in your calculator, and then you need to press your degrees, minutes, seconds button to turn it into degrees, minutes, and seconds. And to the nearest minute, it would give us 65 degrees and 36 minutes. Now, one thing we looked at back when we were looking at trigonometry with degrees was our exact ratios. So we had these two special triangles, which were on your formula sheet, and we had our special angles results for 45 degrees, 30 degrees, and 60 degrees. Now we need to talk about those same exact ratios but in radians now. So if we know that 180 degrees is pi radians, that would mean that 30 degrees would be equal to pi over 6, because 180 divided by 6 gives us that 30. It means that 45 degrees would be equal to pi over 4, because 180 divided by 4 would give us 45. And 60 degrees would be equal to pi over 3. Again, 180 degrees divided by 3 would give us that 60 degrees. So we can still use these exact ratios by converting between our degrees and radians. So for example, if we were asked to find the value of sine of pi over 6, that would be equivalent to sine of 30 degrees, which we know from our triangle, sine is opposite over hypotenuse, so that would be equal to a half. Let's have a look at another example that involves using related angles. So this one, I want to find the value of sine of 5 pi over 4. So 5 pi over 4, we're going to draw ourselves a little diagram. So this is 0 radians. Over here at 180 degrees, that's pi radians, which means 90 degrees is equivalent to pi on 2. 270 degrees would be 3 pi on 2. And back around, if we go all the way around, over here is equivalent to 2 pi. So that means that 5 pi over 4 would be down in this quadrant down here, and it would have a related angle of pi over 4. Now using our all stations to central, that means that sine of 5 pi over 4 would be equal to minus, because sine is negative in that third quadrant. So minus sine of pi on 4. Now we know that pi on 4 is 45 degrees. So sine of 45 degrees. And sine of 45 degrees from our spectral triangles is opposite over hypotenuse. So we would have minus 1 over the square root of 2. All right, one last thing is that we need to use our calculator in radians mode if we're working with radians instead of degrees. So by default, your calculator will be in degrees mode, so it'll either have DEG written across the top or just the letter D. We need to change it into radians mode. Now how you do that, it'll be different depending on which calculator you have, so if you can't figure it out, let me know. But once we've got it in there, we can just type in our radians rather than having to convert them to degrees and then calculate them. So for example, if you put in tan of 1 into your calculator, making sure that it's in radians mode first, to 3 decimal places, that will give you 1.557. So that's to 3 decimal places. If we were asked to evaluate sec of 0.78, again, this is measured in radians, then we could write sec, we know is the reciprocal of cos. So we'd have 1 over cos of 0.78. And again, making sure that that's in radians mode, if we round that to 3 decimal places, we'd end up with 1.407. All right, so that's an introduction to radians.